Hey everyone, so in today's video we will be learning about how to solve the numericals based on inductance calculation. And these calculation is completely based on formula. Okay, so if you know the formula of inductance for a double circuit line or single circuit line or any other circuits, then it's very easy to calculate inductance. Now here the question says three phase and double circuit line. Okay, so in the blink of an eye, just see the end of the question whether to find inductance or capacitance. So here a double circuit line is there, and we see here we can see its inductance. Okay, so first of all, let's write the formula for inductance of double circuit line, which is 2 into 10 to the power minus 7 ln dm by ds, where we need to find dm and ds. It says the conductors are transposed and the radius of each conductor is 0.75 centimeter. Phase sequence is ABC, and here inductance is to be calculated per phase per kilometer. So the formula which is written here, it is in Henry per meter, but we have to find it in per kilometers. Now let's do the basic maths first. Okay, so here this distance and this distance A and C dash, it is given as 4 meters. So the remaining distance will be 5.5 minus 4 divided by 2. So this distance is 0.75 meter, and the other point is it is center to center distances, like, right? So we are calculating the distances from center to center. All right, so due to symmetricity it is 0.75 meter. And now here let's try one by Pythagoras theorem. So we find out, let me do the calculations. See, it is 3 square plus 0.75 square, and it came out to be 3.092 meter. Okay, now let's see the distance between B and C dash. So here it again came out to be square plus 3 square and then under root, which is 6.93 meters. Now this distance is known, now the remaining distance is this. So the distance between C and C dash will be 3 plus 3, which is 6 square, and plus 16, so it is 7.21 meters. Alright, so we have calculated each and every distance, and now we just have to find dm and ds, and we'll put in the inductance formula and we can find the inductance. Now let's see. So let me again write the inductance formula, which is L is equal to 2 into 10 to the power minus 7 ln dm by ds. Dm is mutual GMT, ds is self GMT. Now how to find dm? Dm is nothing but root 3 under root dm1, dm2 and dm3. Now to find the dm1, it can be find out. See, dm1 is mutual GMD, right? So it will be first dm1 will be in between A and B. So dab dash, da dash b and da dash b dash. Okay, so now we just have to find, we just have to write the distances and calculate. So DAB is 3.092 and DAB dash is 6.93 and DA dash B, it is against A dash B dash 6.93. Okay. Now on solving, it is 4.62 meters. So now similarly we have to find dm2. It is between B and C. So it's dbc into db dash c, db dash c dash and dbc dash. Yeah, bc dash. Okay, so because of symmetricity it is 4.62 meter only, and now dm3, it is between C and A. So DAC, DA dash C, DAC dash and DA dash C, C dash. Now it is 6 into 4 A dash C, yeah, 4 into 4 into 6. Okay, so it will be 6 into 4, so 4.898 meters. So now dm will be cube root 4.62, 4.62 and 4.898. So it is 4.711 meters. Okay, so this is the important result. Now let's find out the self GMD. Okay, so self GMD is cube root of ds1, ds2 and ds3. Now where ds1 is equal to between first phase, okay, so AA, so daa into daa dash and da dash a and da dash a dash. Okay, so here the see a dash, it's the 0.7788 r. Just don't forget this term 0.7788 r, and into 7.21 meters whole square, and so 88 into 0.75. See, it is in centimeters, all right, so we have to convert it into meters. Let me 10 to the power minus 2 and into 7.21 square and cube. No, it is, yes, it is 0.2052 meters. Now ds2, so ds2 is in between B and B dash, so db into B and dbb dash, db dash B dash and db dash B. So again it will be same only, so into 0.7788 into 0.75 into 10 to the power minus 2 whole square, it into 5.5, yeah, 5.5 whole square. Yeah, right. So on calculating these terms, we find ds2 as 0.179 meters. Okay, now similarly ds3, it will be dcc dcc dash, dc dash c, and dc dash c dash. So 0.7788 r whole square into 7.21 whole square. See, it would be same as ds1 only, because a and c are symmetrical. See, the answer is 0.2052 meters. Okay. Now ds is cube root ds1, which is 0.2052 into 0.179 and 0.2052. So it will come out to be 0.196 meters. Now from inductance, it is 2 into 10 to the power minus 7 ln dm by ds. Here I already told you it's in Henry per meter, alright, and we have to convert it into kilometers. So to do it, we just have to multiply and divide by 10 to the power 3, and it will be 10 to the power minus 4 ln 4.71 divided by 0.196. So again, it is all calculation based. It's completely, there is no concept here. It is a simple concept of GMD and GMR, and it's just that easy. So it came out to be 6.35 into 10 to the power minus 4 Henry per phase per kilometers. And if we write, it's 0.635 millihenry per phase per kilometers. That's it. So we'll see in the next video. Thank you.